All right, AP Stats Quideo 6, to jump right into it. Does the data provide convincing statistical evidence that there is an association between age group and whether or not a person consumes 5 or more vegetable servings of fruits per day in the United States? Okay, so what the problem also gives us is the table with the information. So this is the observed values they got. That is and then that's the total number of people that partook in the survey. So you can see there and there. So to jump right into it, I basically determined what are they asking. So they're asking if there's an association between the age and the number of vegetables consumed. So I made an HO and HA. So for HO, there's no association between the number of vegetables / fruits someone eats a day compared with their age. And for the HA, there is an association between the number of vegetables and fruits someone eats in a day compared with their age. So for this problem, I had to deal with some of the assumptions, which were, is there a large enough sample size? Yes, 8,866, that's plenty of people to get the survey across. Is the data simple random sample? Yes, it says so clearly in here. All right. So what I did from there is I made an expected values chart to be able to compare it with the observed values. How I got each of the answers is I used the formula, rows parentheses rows times columns divided by the total number equals the expected. So an example of that, let's take this number right here, 18 to 34 in the yes category. So I would take the row, the total of the row, 972, parentheses, and I times that by 2,191, and that is divided by 8,866, and that will give us 240.20, and then you do that for all these. So that will give you the expected value chart. Next, for the DF, what you do is you take the total number of rows minus 1 times, total number of columns minus 1 times the total number of, and then times that by the rows, and then you minus that by 1, and that gives you the DF2. So, all right, so once I made the chart, I then took the expected account and the observed account, and I compared them. And the formula for comparison is parentheses observed count minus expected count, parentheses squared, divided by the expected count. So for an example of this, let's say, take the observed account again for this one, 231, and then I'd minus that by the 240.2, and then I'd square those two numbers, and then I'd divide it by, again, 240. And that would come out to 0.3523. And then I went and did that for each of the rows and column comparisons. And then once I did that, got my final answer of 8.9834. And that would be the chi-squared. So from there, we already have the DF, which is 2, and the chi-squared, which is 0.89. We would go to the chart, and we would find the number. So if we go in the DF, we go all the way over, which is 2, and we find that it's in between, the p-value is in between these two numbers, because it's the number we have is 8.9. So what do? We take that back, and then we drop this. So 0.01 is less than 0.011201 is less than 0.02. So, how I found, and the exact number that was actually in between these two was 0.1121201. I went back and put it through a calculator. So that is our p-value. So, okay, what does this mean? We have the information. What do we do with it? This means I will reject the HO. The data is less than 0.05, which is the required amount. This means that there is that the information that the amount of vegetables one consumed is related to the age. So that means the amount of vegetables one eats is related to the age of the eater. And that's the results.